Cada promès. La processità... no, sia la puja i baixar jo crec que... Sí. I el Javier també, no? No dieu de... Jo tinc el mixer bastant, no sé, yo sé que tanto Jaime como tú lo que nos va a enseñar por la parte que se ponga en el me comenta que o este o el de la crisis. Y este lleva más y esto ya no va a partir de Speaker area. Little Morgan. ¿De qué ha pensado la gente? Tienes que decir a las niñas que, claro, porque la gente no... No, Aquí. Con el de este, tú tienes el next, el back para volver. Le das al next. Ahí, ¿dónde está la tuya? Javi. No sé qué está grabando ahora. No sé.
Hola.
Sí, pero no sé qué está grabando ahora. Bueno, ahora lo conecto. Lo pondrán después de la pausa. Es que debemos estar grabando en el pincho a las 7. Eso es, pasan del juez a un pincho. Se lo diría por aquí, se notifique por la primera fila. No, pues allá. Alicia. Cap al centre. Sí. Per què? Ah. A la zona del centre, sisplau. Ya llevamos el día. Muy bien. 3 minutos.
¿Es esto? Next.
Supongo que es next.
Si voy al next, va a ir al next. Mis cojones. ¿Ves? Mira, aquí vamos mal. ¿Ves? Así no te puede trabajar. ¿Dónde está el pelo? ¿Se puede trabajar?
Guapus, me dan ya orden de iniciar seminario web. Aún faltan unos minutos para empezar, pero ya lo dejo en marcha. Hasta ahora.
Este és next i aquí hi ha el láser.
Vale.
I aquí... Podem fer una prova, no? ¿Ves? Next. Next, pasas al siguiente. Back, vuelves para atrás. Láser. Y ya está.
Hola. Nada, hablando.
Hola.
Cogerlo así. Sí, se puede meter en el centro. Luego vendré y cambiaré. Empiezas tú, gente. A las 9. Faltan 9.
A las 9 en punto empezamos.
Muy buenos días a todos. Realizará la introducción a la jornada.
Good morning. We're going to have Javier Turrón, Head Manager of Camfil, Spain, opening the day.
Sí, buenas. Hola. Buen día.
Good morning.
Bonjour.
Bonjour. Buongiorno. Bienvenidos. I'm just saying this because apart from today, apart from the people we have here with us today, this presentation has been streamed in 5 languages. We've got people all over Europe joining us. So thank you. Thank you for being with us 16 years later. And for the last 4 years, we haven't been able to get together and speak and have a chat. So please allow me to start today with a round of applause to you, to Camfil's personnel who's been working really hard. So a round of applause for you, please.
Bien, 4 años. Si podemos cambiar la diapositiva, Jaime.
So it's been 4 years. 4 years where we haven't been able to get together, but we've worked hard. We've worked a lot on safety, changes, safe process, and you're going to hear that a lot today. Things have changed over the last 4 years. There have been supply issues. There are now energy issues. Camfil has gone back to its essence, which it never abandoned: sustainability. You're going to see sustainable products. What are sustainable products? Not just products that are designed in a sustainable way to be used in a sustainable manner, but also where and how are they produced and manufactured. That's why Camfil, if we could possibly move on to the next slide, we have 33 plants, of which 16 are in Europe, near you. Here in Spain, we have 2 production centers, one in Barcelona, another one in Guadalajara, where we produce most of the products you consume. That is sustainability, and that's what we have been doing. Now, today we are in a safe environment because our air is completely clean, thanks to filters you're all familiar with. And that's all from me. I hope we're all going to have a very fruitful day. Thank you.
Bueno, lo primero, queremos agradecer.
Right. First of all, I'd like to thank you for joining us on this event that we have organized for you. You have no idea how thrilled we are to be back together and to be able to clear some of the queries you put to us every day. If you've had a look at the agenda, you may have seen that we have a busy morning ahead of us. I'm sure it's going to be really fruitful. We're going to focus on things like quality of air inside, terminal cleaning, filtration, containment, or filtration in explosive atmospheres. But before we go on to that, we believe it is essential to go back to issues such as air composition, mechanisms of filtration, or updated regulations on air filters. So let's go to our first presentation with Josep Ventura, who's sales manager for Clean Process in Camfil, Spain. At the end of each presentation, we'll have some time for Q&A, should there be any questions. Thank you. Hello. I hope you can all hear me. Yeah, you can hear me? I hope you can hear me. We're just testing mic. Excellent. Thank you. So I was saying, good morning to you all. Good morning and welcome. To Javier and Jaime's words, I'd like to add that today our presentation is going to be recorded so that in a week or 10 days, more or less, we'll send you to your email addresses the links to access the recordings. So, don't kill yourselves taking notes, because all these presentations will be delivered to you. What else? Please allow me to thank you for being here. I know that we're all extremely busy, and it's great to see you all here with us today. And I also want to thank our speakers today, particularly our marketing department. They've been working really hard to provide us with their presentations, and I obviously want to thank the technicians and for facilitating this event with so many languages and simultaneous interpretation. And without any further ado, Javier has already mentioned Camfil's mission. let me tell you about our vision as a company. Our vision is to make clean air or quality of indoor air, to make it a human right. That was already our mission before COVID. But before COVID, it sounded a bit utopian. Now, after the pandemic, where part of the infectious process was through air, that utopian idea is a lot more real and necessary. So just as it's our right to have access to drinking water from the tap, it's also our right to breathe clean air. Why? Because the air we breathe is very important. Just like us, an average adult, every day we eat about 1 kilo of food, or we drink 2 kilos of liquid. If we were to weigh the air we breathe every day, we breathe 15 kilos of air every day. So think about how important we think the quality of our food is. You know, everything has to be healthy and organic, and the liquid as well. Of course, we want clean air and clean water, and we're willing to pay for it. And we don't really know a lot about the quality of air we breathe. That's how it is. But we will try to make sure that what is now invisible becomes visible. How? Well, at the end of the day, we'll have some friends who'll tell us how we can validate the quality of indoor air. That way we know how, well, what's the quality of the air of the room we work in. So let's go back to basics. What's the raw material? Air. What's air made of? Gases and particles. We're not going to discuss gases today. They'll be discussed in parallel, but we're not going to go into it in any depth. That deserves a whole other presentation. But just to let you know that we have specialist departments on molecule treatment for any issues you may have with gases, I don't know, bad odors, corrosion, whatever. Today, we're going to talk about particles. We're going to see what we filter. We filter either solid or liquid particles with their mechanisms, etc. Now, particles, we have a series of particles outside, and we have to fight them to make sure that we reach clean room quality of air levels. For example, if we want to go to 1 particle per cubic decimeter, what do we find outside? If we live in the Arctic area, in that clean room, we'd have 10,000 particles per cubic decimeters. Now, if we have that room in the rural area, we have 100,000. In the city, 100 million particles. And just as an anecdote, tobacco smoke can have 100 billion particles per cubic decimeter. Now, how about the size? This is to give you an idea of 1 millimeter, which is 1,000 micra, versus 10 micra, 1 micra, or 0.1 micra. You've got to remember that the human eye can see from 10 micra. When we look through through light, through beams of light, shafts of light, we see little particles that comes from to be about 10 micra. Anything smaller than that, we don't see, luckily. But we'll see how many there are. Now, let me show you the 3 diameters of particles that we are going to be repeating the most in this presentation and the ones after. This is 1 micro, 2.5 micros, and 10 micra. Why? Because the current regulation for filters and pre-filters for high capacity are based on these 3 particle sizes, the same as quality of air regulations for Euro M, the WHO. Those are the 3 particle sizes they bear in mind. Here we have a simile of relative size so that you have an idea of what we are facing. If a human being were to be a micra, 2.5 micra would be an elephant. 10 micra would be a whale. Okay, just to give you an idea of what we are talking about. Now, how does these different particle sizes affect us in terms of safety, diseases?
Nosotros tenemos una serie de filtros naturales.
Well, we have some natural filters, which mean that large particles cannot get inside us. 10 microparticles, I don't know, because of saliva, because of our respiratory tract, that means that those sizes do not get inside us. But as particles get smaller, they get further into our lungs. 2.5, they reach our lungs. 1 micra reach our bloodstream. And when it comes to nanoparticles or ultrafine particles, the risk for that is that that particle may get into our bloodstream through the alveoli and reach the different organs of our body, even our brain. Studies are being done to analyze how, for example, air pollution affects brain disease because of these ultrafine particles. So if we take this outdoor air and we analyze its composition, we see that 99.9% of particles are under 1 micra in size. So as I was saying before, luckily, we can't see them because we're surrounded by many, many particles, but we can't see them. So, hey, that's how we can see one another. Other than that, it would be surrounded by fog. But these particles, which are not many, they weigh quite a lot. They weigh 70%. So in number, we have lots of particles which are very small, but very few particles which are quite heavy. That's why when we design an HVAC system, we make sure that the filters get rid of weight from the system, from the air, and then we attack the rest with filters, HEPA or whatever. Then we have a slide with different particles, diameters. You can see a fake classification according to size. We have the smallest ones are virus, then bacteria, pollen, spores. As we were saying, the human eye can see from 10 micra on. And we see how we treat them with HEPA filters, fine filters, or coarse filters. PM 10, 2.5, or 1, what does that mean? Particulate matter. So from 10 down, 2.5 down, and 1 micro down. Apart from the particles we find in the atmosphere, we also generate our own particles. Human beings shed particles. So any small movement we make might mean 500,000 particles of 0.5 micra being shed by minute. So we are constantly shedding particles. That's why in white rooms, in controlled atmospheres, you require certain PPE to make sure we don't generate particles. And also in a clean room, we may have machines, things that generate particles. So apart from inside indoor filtration, we need to renew the air to get rid of those particles. Those particles may be viable, not viable, maybe chemical products, or maybe microorganisms. So there are different types. Now, particle movement. Here we have an example of how long it might take an 150 microparticle to touch the floor if we were to launch it from 2.5 meters high. So 150 micro, 5.4 seconds. If we go to 0.1 micro, it would take it 34 days. So small particles are not really going to deposit. They just float. And that's why filtration or venting airs, laminar or turbulent flows, just sort of nudge them, invite them to leave those controlled atmospheres. Now, within particle movement, we have the smallest particles have certain movements which are very important, as we'll see in mechanisms later, what we call Brownian movement, and the bigger ones have gravitational movement. They fall by their own weight. Then we have electrostatic, of course, but that's apart from that. We'll discuss that later. Now, filtration mechanisms. We've talked about air, what we need to filter. Now we'll see how this works to capture all these particles. First, we have the mechanism of filtering of the mesh effect. A particle which is bigger than the mesh is not going to go through. It's like a colander, like a sieve. But this sieve effect only works for very large particles, and it only gets rid of very few particles. Then we have inertia. This works against smaller particles. We give the particles some speed, and that means that sooner or later it may impact one of the fibers in the mesh, and the mesh will capture the particle. Another mechanism is interception. The particle doesn't need to hit the fiber head on. It just needs to brush against it and will capture it. And finally, and this is what really allows us to get rid of most particles in the atmosphere, is the diffusion effect. And this is how we have absolute filters. As we saw before, the smallest particles have these kind of Brownian movements, as we called them before, and that means they cover a lot more room than they would if they were to have a linear movement. That means that sooner or later, because they're covering so much room, sooner or later, they're going to be captured by any of the other mechanisms we saw before, inertia or interception, and they'll be captured by the filter or the fiber. Now, through this diffusion effect, we retain about 70% of the particles that go through the filter. And then we have the electrostatic effect. Now, it depends on the material. It's usually for synthetic. They may have an electrostatic charge, and this attracts particles the way a magnet would. The problem is that this electrostatic charge disappears with time, and then you're just left with what you had before. We'll see this with the regulations later. Now, the combination of all these mechanisms generates this global efficacy curve. This is the inertia and sieve mechanisms, diffusion, interception, and the sum of them all gives this total efficacy curve with this MPPS area, which is very important, particularly for absolute filters. So we've seen what we filter, how we filter it, and now we need vocabulary to discuss what we are interested in. This comes from the regulation, the classification of filters based on certain standards. Pre-filters or high-efficacy filters are regulated by ISO 16890. Before it was EN 779, and absolute comes from EN 1822, and there is now ISO 29463. We'll have a look at them and how we classify these filters, so that when we talk about norms and standards, we know what we're talking about. This is a little bit of background on standards. USA, Europe, the ASHRAE standards have been updated in USA, then in Europe, Eurovent, and EN 779, and they all converge into ISO 16890. 16890 defines 4 steps for filter classification. First, the measurement of the initial efficacy, then we have to discharge the filter electrostatically and then measure the efficacy with an discharged filter. This gives us a classification level between the 2 parameters we've seen. We'll give you an example in a minute. For this, we use for small particles, we use DES, which is the test aerosol that we use for absolute filters, and for large particles, we use SALT, KCl. This is your typical test bench for standard organisms, or we ourselves in our research center in Sweden. And this is where high-efficacy filters are tested. We had a look at PM before. Now we have EPM, which is efficacy on 10 microparticles, efficacy on 2.5 particles, and efficacy on 1 microparticles, EPM. Now, this is how it is distributed. The standard says that we need to test the filters in different diameters and see whether they pass the level required, starting with the smallest size. If we reach 50%, we're there. If we don't, we go on to the slightly bigger size. If we're there, great. And if not, we move on to the next size and so on. The best filters will be EPM1, and the most basic ones will go to coarse levels, which are even bigger than EPM10. And then there are a whole series of data that need to be reported at in our classification report. This is a huge array of efficacy levels, but then when we provide a product, what we do is we simplify it with a single classification. But the standard does give us all these levels of efficacy with the requirements of, as I said before, you need to pass 50% at initial filter and discharged filter. Let's have a look at an example to see how this works. For this, we have prepared 2 filter models. In the previous standard, they were F7. So we've taken an F7 filter for EN 779 without electrostatic effect. There is no electrostatic effect. And we see how initial efficacy for the filter in PM1 is 60%, then 74%, etc. And then when we discharge it electrostatically, it remains pretty much the same. Why? Because these filters, by nature, their material is efficient in itself. It doesn't really require any electrostatic charge or anything. Then the standard says that we need to have the average between these 2 measurements, and it is the average that will give us the classification of the filter. So we see how for EPM1, both the initial and discharged is above 50%, and that was the requirement set by the standard. So we do the average, and we have to round up. We are at 64, so we go to 60. So the classification of the filter is EPM 60. and we can classify it as EPM1.
Anteriormente era un F7 también, pero que en este caso sí que
Now
tiene
we
cambio.
have a filter which was also F7, but it did have electrostatic charge. We see how initially it looks like a good filter. I mean, it appears to be even better than the other one. But what happens when we discharge it? Not so good, right? There is quite a difference between initial filter and discharged filter. This happens. Yeah, you may have this in a climate control unit. I mean, it's going to happen. Luckily, the regulation, what it does is it's a little bit more transparent with these filters and it can spot them. So again, we work out the average and can we classify it as EPM 50? No. Why? Because the requirement was that both for initial and discharge measurements, it had to reach at least 50%. So this filter cannot belong to the EPM1 club. It needs to move on to EPM2. Here, initial and discharge is over 50%, average, round up. It's a neutral number, and it can be classified as EPM2, well, it's 2.5, EPM 2.5. So in order to be EPM1, you've got to comply with certain requirements. If this filter hadn't made it to 50, if it had been 49, then it would be EPM 10. And that's how the standard classifies filters. And this is the report generated with the different laws of initial filtering, discharge, dust collection, and final classification. Then, apart from the efficacy classification of filters, something else that's important, increasingly so, unfortunately, is the whole energy issue. A filter consumes energy. It's a block that consumes kilowatts constantly. So what we need to do, and we focus on that, is to make sure that the loss of charge of this block element, this plug element, has to be light. So this is easily classified through Eurovent. They've got a website, which is euroventcertification.com, and there we have a classification of filters according to energy efficiency, just like washing machines or fridges at homes. The same thing goes for filters. So you can take an EPM1 filter and see, A+ consumes 800 kilowatts a year, whereas a B consumes 1,000 kilowatts a year, so 200 kilowatts a year. I don't know how much you're paying for the kilowatt, but if it's 0.2, I don't know. Lucky you, I pay a lot more. But if it's 0.2, that would be 40 euro. I mean, 40 euro for one filter a year. I mean, that's sometimes more than the price of the filter itself. So that's an easy way to compare products and filters through its energy classification, energy consumption. So we know that a good product needs to be EPM1 first. And then in energy terms, ideally, it should be A+. So when it comes to specifying or choosing or finding a product that is going to go at the end of the climate unit or protecting a HEPA filter, a recommendation, a possibility would be to request an EPM product, so the higher the efficacy in EPM1, the better, and A+. With that, we know that this is a really good product. That's a simple way when it comes to standardization. Now, HEPAs. We've had a look at high efficacy filters and pre-filters, their classification. Now let's have a look at HEPA filters. Historically, They come from the Manhattan Project, the creation of the atomic bomb. The idea there was to find a filter. They called it an absolute filter. They still use that term because the idea is that it should retain as many radioactive isotopes as possible, because there was going to be isotopes in the research process. Through the years, many other applications for HEPA filters have been found. For example, microelectronics, hospitals, food industry, nuclear industry, turbines, biosecurity, and the pharmaceutical labs for clean rooms or white rooms. HEPA filters are part of many, many standards and regulations. FDA has something to say about them. EMA, ISO 14644, EN 171400 for contention level 3. And the standard also tells us how to classify the filters. Now, how are the tests carried out for all this? Now, this is no longer high efficacy filters. We're going to count particles. Before we were talking about masses, micrograms per cubic meters. We were counting mass, weight. Now we're going to count particles. As we saw before, the figure is small particles, how many there are. So SDS is you count particles before the filters, after the filters, and see how many or which particles are the hardest to filter. That's the DES. And this is MPPS filter, the point. A HEPA filter has a minimum point of efficacy. It's called MPPS, most penetrating particle size. And that is the particle size that is going to penetrate the most penetrating particle size. So if the particle is bigger than that, it's going to be easier to filter for us. If the particle is smaller than that, it's easier as well because of the diffusion effect. Remember that the smaller the particle, there comes a point that the more they oscillate. But there's a point where they are hardest to filter. That's the point we use to classify our filters, the MPPS. This MPPS point is what we use for these classifications when we talk about efficacy, H13 99.95. That's MPPS. That is the hardest to filter particle size. So when people say, so what happens with a virus or a bacteria? Well, I don't really care. I'm talking about the most penetrating particle size. Anything else is going to be easier to filter. I'm giving you the hardest one, okay? That's MPPS. The classification then gives us from E10 to E12 to EPAs without H. And then we have H13 and 14. Those are HEPA with an H. And then we have more efficacious filters, ULPA, which are usually used in microelectronics. They are higher efficacy. This is for N1822. But then we said that there is a new ISO standard. This ISO standard intersperses within this classification other classifications, because when we combine the European and the American regulations, the Americans tended to use 99.99 or 99 whatever. So in the combination, they have maintained all classifications. So we now have interspersed some intermediate efficacies, but the test mechanisms are the same. And this is going to be the regulation that we're going to use the most. We have a typical test for a HEPA filter with all the data from scanning. This is local efficacy. So if one of these points were to go through the dotted line, that would give us a local leak. So we'd need to repair the filter or reject it.
All these local efficiencies will give us well, here we have the target that we're looking for. In this case, it's an H1495 with 95 Pascal at the nominal flow. What have we achieved? We have achieved a 99.997 with 97 Pascal as a target. We have achieved our goal, and the filter will be classified as H14. In this case, a particle diameter that took us longer to filter is 0.18 micron. MPPS is between 0.1 and 0.2 micron. This is the gauge, the regular gauge we have with the COVID issues. We had to work on filtering viruses, etc. With the efficacy we give, well, we filtered the virus. And then minimum efficacy levels, the testing parameters, etc. And since I am running out of time, here we have different terminology that we use with absolute filters efficacy of the filter, the efficacy of the filter, physical resistance. This is the resistance that the filter should have so that we cannot break it when we handle it. The difference in pressure, the filter that has before and after the flow, well, shelf life when we have a HEPA filter will depend on the pre-filtering levels, how many hours it works, the aerosol levels that we send when we do the integrity tests, efficacy. Well, in a HEPA filter, we cannot lose any efficacy. The first day it has to be as efficient as the last one or even more. We cannot lose efficacy with HEPA filters. The particle charge is the retention capacity the filter has, or the oil particle filter through the aerosol that we generate to do the integrity tests. The filter should be ready to retain all this oil, so that we don't change the charge capacity. And the reason to Camfil products, we use the decontamination products, the ducts, decontamination, etc. Places where we can find HEPA filters includes HVAC, terminal impulsion boxes, air purifiers that had a former moment of glory, and that will be used in the future as well. And the the isolating systems with clamps, etc., with different filtering materials that we use for the filters, for the HEPA filtering. Well, so far so good in my presentation. I hope you liked it, and this is it. Thank you. Thank you. Well, thank you very much, Pep. Any questions with respect to the issues that acted as a reminder for us? Well, let's continue with the next presentation, which is air filtration in explosive atmospheres. Oftentimes, we don't really know if a piece of equipment should be certified for its use in explosive area, like sealing housing, air extraction housing, in a room, etc. Should they have this type of certification? In order to answer these questions, we have Volker Parton, one of the main persons of reference in Camfil in the design and production of housing, and Gabriel Senetti, the sales director in the air capture in May.
Thank you, Jaime. Good morning. Welcome, everybody. I'm Volker Parton. I'm with the Camfil European Metal Center, where we build most of our investment equipment, basically metal filter housings for controlled environment, be it safety housings with a bag-in, bag-out filter change options, or our family of terminal housings, equally for controlled environments, typically pharma industry, biolabs, hospitals. And our topic today is the ATEX directive. We split that in two, between myself, for HEPA HVAC equipment and dust collectors. And as you will see, there is not much in common. The ATEX directive, or what is that? And how does it relate to HVAC HEPA housings? ATEX is a simple acronym describing a situation of explosive atmosphere. Easy enough. And the directive, it's defined as, well, you have to reunite basically three conditions to be in that situation. Your situation should be, or has to be, a mixture with air. And what's the interesting part in the air is obviously the oxidizer, oxygen. You have to include some form of combustible substance in that air. That may be gas, vapor, mist, or dust. And you need an ignition source. And note, the specification expressly includes, after that ignition, the combustion needs to spread to the entire unburned mixture, and that what defines the explosion. So you have to have the full collection of this unholy trinity of criteria to be under explosive conditions. For practical purposes, you actually have to consider two more criteria. Mainly the dispersion or the concentration of your combustible. Not everything is flammable or explosive in any mixture within any environment. And also confinement. What is your confinement? Does this happen in a little box? Is your confinement the room? If you have explosion, might that confinement burst? Then you get an effect like a grenade or a bomb. And you might get secondary damages that might actually be way more important than the initial one. So we're actually talking about a little pentagram here. Oxygen, sorry, wrong button. Oxygen, you always have that. You need your combustible dust in a certain environment with a certain concentration. And if then you have a source of ignition, that is your risk, that you may actually get an explosion. And why consider this? Well, because first, the consequences may be dramatic, and also they are much more common than one might think. An estimated 2,000 per year in factories and refineries around Europe. Well, not all with that extent, or this would be a much more present and public topic. But while picking one country, 50 reported dust explosions in the UK alone. That is one per week. So indeed, we have a significant cost risk and a significant health risk for people working in those environments, and that has been acknowledged by the authorities. So this ATEX topic is ruled today by two European directives about danger zones and decertifiable equipment. So on one hand, for the users, you get the so-called ATEX workplace directive that is no more nor less a definition of minimum requirements to enable people to work under safe conditions in these environments. And on the other hand, for suppliers, you get the product certification directive, which obviously and luckily is mandatory to get equipment for use in those explosive atmospheres. In more common terms, you could say, on one hand, you get a classification system for areas and zones which characterize your risks with a certain ranking depending of what kind of combustible you encounter, in what frequency this might appear, if it appears, how long it lasts, how sensitive to ignition events this might be. And on the other hand, an equipment category system where you have safety levels and certifications that stipulate this equipment will be suitable for safe operation in those and those areas for those and those safety levels, including a very clear labeling that shows you on the product that is where you can use this equipment safely. In practice, I'm going to go through this very roughly just to establish the landscape, if you like. The basic certification, you get indeed the occurrences continuously, occasionally, rarely from 0, 1, 2. And note, we get 2 parallel classifications, one's for gases, one's for dusts. And to those correspond equipment categories, what kind of safety level equipment is safe for use in those. As the saying goes, who can do more can also do less. So the temptation might be take the easy approach, using category 1 everywhere, when you don't need to think more. That works technically, but will cost you dearly. As we will say, you should not take that easy road. For gases, there's a second level. Well, we're not in the mining industry, so everything in our industry will essentially happen in group 2. And here you find the notion of temperature. Temperature contact, open flames. Impact, we can use the proverbial bad boy hydrogen as an example. It is notorious because it is very difficult to contain. The molecules are so small. And is also notorious because it has one of the widest range of flammability. Hydrogen can go explosive in mixtures with air from 4 to 75%, which is extremely wide, and which makes it so dangerous. So if you get like surfaces around 450 degrees, you'll find yourself with a hydrogen in the most critical category. 200 degrees less, you get 1 degree less danger of danger of actual risk. Not to say that that is a low risk. So that looks pretty straightforward, very structured, very clear. And as far as HVAC equipment goes, there's only one problem. The ATEX directives does not actually cover those equipment and were actually formally excluded. And I cite from the ATEX guidelines, if the only source of electrostatic charging comes from the process, such items are not considered to have their own source of ignition, and they are not in the scope of the directive. In those cases, they should not be ETA X or CE marked. Well, that is not the latest directive, but the statement is still fully valid in the current directive. So what now? If we look at what happens in HEPA filters, HVAC housings include typically no electrical equipment indeed. The only source of electrostatic charge is the friction of dry air on surfaces that may be non-grounded, indeed from the process. Direct conclusion, HEPA filters, HVAC housings have no own ignition source in terms of the directive. What do we conclude? We're just not concerned. As a first thing, we have to conclude, well, we can't have the classic ETA X logo. There is no formal ATEX labeling, and there will be no formal ATEX certificate. To be very clear, we're talking about HVAC HEPA housings for controlled environments, meaning you have almost per definition very low dust loads, not to be confounded with dust collectors that deal per definition with extreme particle loads. They also generally have some electrical equipment. So those are fully and officially certifiable, and Gabriele will tell you all about it in a few minutes. But still, there is at least a perceived problem, because end users, they do want to operate equipment that is safe. They also want, if they have ATEX conditions, they want a certificate to stipulate, yes, what you bought is safe to use, because there are regulations, there might be internal procedures, there are documentary purposes. And on the other hand, the manufacturers want to propose a full range of products that are asked for by the market, by their customers. So we have what I call a documentary gap between what regulations formally allow and what common sense seems to demand. Seems being the key word here. So to fill the gap, from a practical standpoint, we can propose equivalent certifications. INERIS is a renowned institute in France. Like others, they have detected this gap as a market, and they propose certificates which are fully compliant. The only thing that is different from this kind of certificate to an official ATEX certificate is that we can't call it ATEX. This is executed along the same technical guidelines, and it gives you a fully compliant rating system. In practical terms, this is an ATEX rating. It is also a notified body, so this certificate comes with all the guarantees, since it's backed up by regular audits to make sure the products do still conform to what was certified. In terms of product range, there is mainly the Camfil family, so ducted bag-in, bag-out safety housings, and the modular configurations based on that family. It starts with single housings, but does not stop there. There are other functional modules, supports, collectors, particle injection systems, integrity testing devices for the filters. Okay, who says HEPA? There's also filter validation. And all of those are eligible to the electrostatic rating of the base housing. This is actually regularly requested. Those housings are typically most often in the technical area or in the wall of the clean room. We can go up to banks of 5 filter cell housings in parallel, and everything can be covered. The other aspects are, for example, terminal housings for walls and ceiling. This is very much more exotic, actually for good reason, as we will see. And right now, they are not certified yet. We are in the process as a reaction to the request from the market. We should have a certification level beginning of 2023. So how to approach this ATEX topic for housings where the reg limitation says you're not even concerned? Main principle is the manufacturers can only help you so far. We can design our products, we can have them qualified to a certain category, and then you get aptitudes for use in more or less critical safety zones. The customer is in charge of his installation, a layout, and what is called zoning. They must define their ATEX safety requirements first, and the manufacturer can't help them with that. And keep in mind, without optimized zoning, we'll get to that a little bit deeper, you will find yourself with higher risk levels, especially zone 0 and 20 for dust and gases respectively, meaning that would require more sophisticated, more expensive equipment. So the consequences can be quite important. But okay, consequences. Let's talk about sources first. How about ignition? Statistically, a little more than a quarter of ignition events are, well, mechanical sparks. grinding, hammering, not typically something that I would expect in a clean room or controlled environment. Another quarter, human error. That is difficult to exclude anywhere. Then we get static electricity, including both from non-conductors, plastic parts, but also from conductors, metal parts, which are insulated in their environment, which are not grounded. And those are actually the more dangerous ones, since they can carry important charges. After you get things like fire, open flame, typically not something in a clean room either. Hot surfaces, motors, bearings, depending. You might have a mechanical issue here, and then something that's not supposed to get hot might get hot. Self-ignition, and all the rest. Mainly, we will be concerned in controlled environments about static electricity. And 9% is, well, let's say just enough to be uncomfortable. Yeah, only 9%, but yeah, as much as 9%. So what should you do? Well, you should consider the actual risk. Where are we here? We are in clean room, controlled environment surroundings with this type of products, where you have almost by definition extremely low particle concentrations when we're talking about dust. So reaching actually flammable concentrations should be almost excluded, except accidental events or special areas. You also have typically high air renewal rates, from like for an ISO 8, like minimum 10 times per hour to over 300 times per hour, associated with often the request for laminar airflow, meaning high renewal rates, but very low air speeds. That is also not really pushing the danger as far as static electricity goes. So is it actually possible to encounter ATEX concentrations, even considering accidental isolator leaks? Is it actually possible or probable to encounter electrostatic charges strong enough to create the spark? How dry is your process air? How fast is your airspeed, which is a measure of the friction? If you come back to our pentagram, well, the oxygen people in the room will want to breathe, so that we will always have. Risk factor, yes, but combustible dust, its dispersion, its confinement, that is not a high risk in those environments. And ignition is actually the one element we can actively take care of in housing by designing it in a way or upgrading it in a way that all elements are grounded and static electricity, does not accumulate. So we try to eliminate ignition, which means the whole ATEX risk actually goes away. So assessment and cost mitigation will be the main task here, which passes via the activity of zoning, and that may have important consequences. Your classic image of a nice, clean room. And when I say clean, please remind, in an environment like that, it's not only about the air quality. Typically, people will also want to decontaminate this area from time to time or regularly. So with some equipment might even look like that. If you're not careful and put all category 1 equipment, you might end up looking like this. Now, this is obviously not a clean room, that's a ship's engine compartment. Per definition, an ATEX environment, if you like, we have all the factors combined, but it's not a completely crazy analogy. As for an example, I'll give you a manometer. If you're filtering, if you're having HEPA filters, you will want to trace the lifetime of your filter. You will track the pressure drop. Basically, you will want to have a manometer per filter cell. A normal manometer, you can buy it for 150 euro or less. if your analysis has told you, well, I will need an ATEX environment, then the same thing will cost you more than 2,000 euro. And from the decontamination standpoint, it's not only getting much more expensive, it's also getting much more bulky and convoluted. So zoning is important. The important fact in zoning is only because you have some really critical zones does not mean the whole area around the zones has to be classified as zone 1. On the contrary, well, this is like a schematic of a petrochemical plant. I like that better, more accessible to everybody. Your fuel station where you fill up your car, the underground cistern with the truck, the actual flammable material is not considered ATEX because there is no air. This is only combustible and nothing else. The little volume, the air over the liquid, where you get lots of fumes, that is, of course, a very critical area. These zones where you have interfaces, hookups, filling up, risk of spillage, risk of evaporation of that spillage, zone 1, little buffer zone 2, but here in front of the car, you're not under ATEX conditions. And that is the key to really determine where is the risk. If you take this analogy to a controlled environment room, you could say, oh, if you have a dust products that you need to mix and you get a bag that bursts and you get a huge cloud of dust, that doesn't mean because of that risk, you have to fully equip your entire room with ATEX class 1 equipment. Think of confining that area locally. Think of extracting that risk locally when it happens. Same for gases. Hydrogen is lighter than air. If you have something, you will typically pool on the ceiling. And don't wait to create a pool. You can put an aspiration there and extract it before you reach critical concentrations. So that is the idea. Assess your risk, look at what's really happening, and avoid or limit the size of zone 0, 20, because those will cost you dearly. That is the recommendation we can give you for HVAC equipment. Really look at the real risk. Formally, the directive says you don't have to do anything, but you should take the risk seriously. If it is there, assess it, act in consequence. For dust collectors, the deal is completely different as the environment is different. And Gabriele will tell you all about it. I will rejoin him afterwards for questions, should there be any. Thank you.
Just said, for dust collector, the story is quite different because the dust collector is something that can actually explode. So actually in dust collector, we have all that we need for an explosion. We do have oxygen because it's always present. We have dispersion, we have confinement. The dust collector is a place where there is a confinement of dust. There may be a combustible dust. So we only miss the ignition to create an explosion. If we add the ignition, then we have an explosion. And this is what can happen in case of an explosion. This is an explosion created during our testing. We have been performing a lot of testing on our dust collector to simulate explosion. Testing is actually very important when we deal with explosion dust collector. And the dust collector is actually a place where it's very likely to happen an explosion. We can see from the statistics here on the screen that in a certain industry, like almost 1/4 of the total explosion are happening in a dust collector. So yeah, it's risky. We need to take care about the risk. But what is exactly an explosion? Basically, an explosion is a combustion of very fine particles, okay? So if you have a piece of wood and you give fire to it, it will burn nicely. If it's in your fireplace, in home, it's nice. It's nice to see, okay? But if you disperse wood fine dust in a confined environment and you give an ignition to that, then it will be an explosion. And you don't want to have that in your house, right? Okay. Apart from, okay, and then basically this happened because when the particle is very fine, the surface exposed to the oxygen is much bigger than for a big piece of solid material, okay? And so this creates a much faster and much more powerful combustion that create energy, temperature, and then the shock wave that is typically the first explosion, the primary explosion, okay? And then if the primary explosion is not protected, what happens is that there will be a secondary explosion in your plant. The secondary explosion consequences can be very dramatic, okay? And that's all depend from how much dust is around the environment. So we can see here in the picture some quite dusty environment. That's quite dangerous. This is picture we're taking from a sugar factory. Sugar is very, very, very explosive, and in such an environment with all that dust around, a secondary explosion can have dramatic consequences. It can kill and injure people. So a very first thing, so we'll come back to that when we deal with the potential explosive dust, is keep your environment clean. Cleanliness is the first important things for avoiding explosion, actually the effect of secondary explosion. So here we have some nice images showing what happened in case of an explosion. So let's say we have an explosion now with dust collector and there is no protection. So the explosion go back in a pre-filter, and they go back to the plant, propagating to the ducting, and it can also destroy the ducting and propagate to the plant, and so on. So propagate, going back, and then all the system starts shaking. Okay, so there will be even larger dust cloud, and then boom, a big disaster. Okay, this is what we want to avoid. But another important point is that sometimes we think, oh, that thing that is going to explode is very small, so I'm not that concerned about that. Well, it's not really true. Even take a look at this video. Yeah, this is a small explosion. It's 100 liters, but you don't want to have that in your factory, right? Okay, of course, bigger explosions are much more dangerous and scary. So the first step is defining whether the dust you are handling is explosive or not. There is a very large amount of dust that are explosive, and the large majority, almost all the pharmaceutical dust are explosives. And today we are talking about pharmaceutical applications. So here, ethics is a big concern because the majority of the dust you're handling every day are explosive. In order to understand whether a dust is explosive or not, we need to dig into the property of the dust, and we need to do some testing. So it's important to know the chemical composition of the dust, the size of the particles. As I mentioned before, the more surface is exposed to oxygen, so the finer is the dust, the more dangerous is the dust. The energy and the temperature required to initiate the explosion, and the energy that will be released in case of an explosion, as well as the probability of self-ignition. So these are the properties, and those properties are actually formalized in certain value. For example, how fast the reaction will be in case of an explosion is formalized on a value called KST that is divided in 3 categories. 33 classes, ST1, 2, and 3. 1 is from 100 to 199, 2 is from 200 to 299, and is measuring bar meter per second. And 300 is ST class 3 is 300 and above. So in that case, we need a proper KST value because it's undefined the upper limit. And that's how fast the reaction will be, and then we have the maximum pressure that we will reach. Okay, so basically the Pmax, as we see in this graph, it gives you a measure of how fast we will reach the maximum pressure. So the higher is the KST value, the faster will be the reaction, the faster we will reach the maximum pressure inside the dust collector or any other confinement environment. Then it's important to take into consideration how easy it is to ignite the dust. So the minimum energy required for ignition, MIE, typically is measuring millijoule, and typically value below 5 millijoule are low value, and the temperature that is called is a MIT value, minimum initial temperature. Then dust is then grouped into dust group. 3A is fibrous dust, 3A is organic dust, 3B is fibrous dust, and then the metallic dust on 3C. But yeah, this is just a conventional classification. Okay, once we know whether our dust is explosive or not, we can start considering how we can reduce the risk of an explosion. So I divide in 3 major steps. So step number 1 is reduce the amount of dust that is around. So keep your environment clean and install a proper dust collector. So a dust collector is a first layer of is the first step towards safety in a plant, because it's extracting and containing dust. So it's avoiding the dust to spread around. So this is a very first step in keeping your environment clean and avoiding possible explosion. The second step, as Volker mentioned before, is avoiding source of ignition. So we need to make sure that every equipment we install are proper for the zone where they are installed, and they are certified for that zone, so that we will avoid any ignition source. But even if we take all the measure to avoid any ignition source, we cannot really consider that there will be no chance over any possible doubt that there can be an explosion. So we need to take measure to limit the damages in case of an explosion. So these are the 3 steps. So step number 1, as I said before, is keeping your environment clean. So making sure all the dust is extracted properly, making sure you have some housekeeping activity, removing all the dust from all the machineries in order to make the environment clean and avoid that the consequences of a secondary explosion. So and also the dust extraction toward the dust collector need to be properly designed so that the dust is collected in a proper way. Here there are some example of bad environment. So a lot of dust around, that's very dangerous, or even bad habit. That operator is feeding a mixer without any particular protection. So every time we'll feed a mixer, we'll create a dust cloud that is potentially explosive. Or some dust covering an electrical motor that will generate heat. So we'll potentially, if we overcome the minimum initial temperature of the dust, it will start an explosion. So we need to avoid those situations by keeping our environment clean. And that's the very first step in protecting our factories. It's important to keep also the floor clean. And here, something that is a bit against common sense, even 1 millimeter, a layer of dust of 1 millimeter can be extremely dangerous, because it can create concentration of dust in a cloud 5 meters high of 100 grams per cubic meter. That is something that starts to be dangerous. But in a cloud of 1 meter, it is 500 grams per cubic meter. That is sort of optimal concentration for a dust explosion. So even 1 millimeter of dust can be extremely dangerous. So if you can see your footstep in dust plant, okay, that there is a risk. There is a concrete risk of dramatic consequences. The second thing, as I said, is avoiding ignition. And as Volker said before, we need to take measure to make sure that the equipment we install in a certain zone do not generate any ignitions, and there are certifications depending on the zoning. Basically, we need to avoid that any spark is generated. But let's go to the protective system, the one that, let's say, mitigate the consequences when an explosion happens. Here we have a picture of the Concorde, just to say that even if you have a very well-designed, modern, state-of-the-art machinery, it's impossible to say that is completely safe. Okay, for the one who don't remember, the Concorde had a terrible explosion in 2000 and was removed from the market, but was a superjet, the fastest airplane in the world. So it was a state-of-the-art equipment, but then it failed anyway, and failure may happen. So it's important that other than designing the synthesis, the safe systems, we take into consideration that phase may happen and we need to mitigate the possible consequences. And that's the third step in safety. So the purpose of the protective system is to make sure that in case of an explosion, the consequences will not be dramatic. And we need to protect. We need to make sure that the dust collector can withstand the explosion or prevent the explosion outside, or having a system that will contain the explosion. We need to make sure that the explosion will not propagate back into the process. And if we recirculate the air, we need also to make sure that the explosion will not propagate in the outlet of the dust collector. Or if we discharge the air in an area that is not safe, we need to make sure we don't pose at risk situation. And Camfil is offering a range of protective equipment for our dust collector. Here we see some. So we have vent panels that are actually venting in case of an explosion. So the explosion will propagate and not generate the drastic consequence. So there will not be a tremendous pressure inside. This, of course, need to vent the air outside. In case of indoor installation, we have flameless vents, but it can also, the explosion can also be avoided by suppression system. So system that put into the system suppression dust. We do offer isolation valve in the inlet side, and if it's required, also on the outlet side. Or we can also offer a chemical barrier for the inlet side. So the proper protective system depend on the application, depend on the dust, and depend on the dust properties. So once we know the dust we need to handle and the characteristic of your application, we can advise the proper protective devices. Of course, this is just a picture where we are putting together different options. We don't use all them together. We use one another. For example, the suppression system is an alternative to the vent panel or the flameless quench. We at Camfil will always offer you dust collector with safety first in mind. That means that the inlet side of the dust collector will always be protected. If we recirculate the air, the outlet side will always be protected, and the dust collector can withstand the explosion. And sometimes there is a common belief that it's possible to install dust collector taking into consideration that there will be no ignition sources. Well, I think it's dangerous. If you see the statistics coming from some literature in terms of sources for dust emission, 20% of the sources are by unknown factor. So it's very, so it's quite big number, huh? So it's very difficult to actually eliminate an unknown factor. So in our opinion, we always have to take into consideration that it's impossible to completely eliminate all the ignition sources. So we need protection for case of explosion, even if we take all the possible measure to avoid all the ignition sources. So we need protection anyway. And one common protection used in the pharmaceutical plant, that is something that avoids explosion, is the chemical suppression, that is based on a fast detection and the injection of a suppressant dust inside the dust collector, so that will contain the dust and the explosion, and the explosion will not happen. We have different brands for this suppression system and different models that are applicable to different type of dust, different KST value. So most of the manufacturers are limited to ST2, but we have some that can go even higher, like 330 bar meter per second. The sizing is done by our engineering, depending on the dust characteristics. Another very common way of protecting is the use of fast-acting valves. So the fast-acting valve are based on a detection system and then an isolation. And this makes sure that the flame will not propagate. It's very fast detection and isolation. And that's typically installed on the inlet side to avoid that the dust will, the explosion will propagate back into the system. But it can also be installed on the outlet when we need to make sure that if we recirculate the air, or when we need to make sure there will be no explosion going outside, or for containment purpose, but we'll come back to that later in the following presentation. Here, it's as I mentioned, containment purpose, and here there are two videos. The first video that is showing there is a lot of smoke coming. I mean, there's no flame coming out, but a lot of smoke. So if we are handling a toxic dust, that can be a problem. And that's the reason why a fast-acting valve can be better, because we can see from this video a real amount of dust going out from the explosion is much less in that case. It's very minimal with a fast-acting valve, while with a suppression system, there is still a lot of material going out, even if there is no flame. So it's safe from a explosion perspective. Camfil offer a complete range of dust collector that are explosion proof and especially dedicated to the pharmaceutical industry. We start from our general purpose dust collector for containment application, that is the Gold Series Campaign. It's a modular system, so it can basically be used in any pharmaceutical application, from small volume to large volume. Then we have a range of products dedicated to HVAC, so high vacuum cleaning, a centralized high vacuum cleaning. And basically we have two models, a mini and the Gold Series, and we can go up to 6,000 cubic meter an hour and a negative pressure on minus 50 kilopascal. Then we have our product range for when a compact design is required, is the quad pulse range, the QPP1 and the QPP2. QPP2 up to 3,000 cubic meter an hour, and the QPP1 up to 1,200 cubic meter an hour. This system are particularly good in where there are some space constraint, and when the system need to be installed in a limited space, and we have also limitation in terms of venting in case of explosion, because the QPP are, we'll come back to that later, that are explosion proof. In other words, in case of explosion will happen inside the dust collector, it will remain inside the dust collector. They don't need any venting or suppression system. We come back to that later. So if we look at the common causes of an explosion, it can be bad design, no proper analysis of the function, lack of maintenance. Yes, maintenance is also important, because we can have a well-designed system, but we don't do the proper maintenance, then, you know, it's worthless. The well-designed will not last. No routine or regular inspection. So the system was originally okay, but we don't perform the proper inspection. Lack of training. So the people who perform inspection and maintenance do mistakes because they are not trained enough. Or a very common mistake, I did that low risk procedure 10,000 times, but it's the +1 time that create the explosion. You know, when we drive, we all think we are the best driver in the world, and we take some risk, or not all, but you know, some of us. And then, but there is one day that we may fall into troubles by taking those risks, even in a everyday activities like driving our car. Another important point, a common source of trouble is changing the process without doing a reanalysis of the risks. This is also something that need to be avoided. And final, last but not least, insufficient knowledge. Yeah, if we don't take the necessary step and we don't have enough knowledge to evaluate our risk, that's very dangerous. And we see that most of those common causes are based on human error. So human error is something that need to be taken into consideration when we talked about ATEX and we talked about explosion protection. So when we design a safety for explosion-proof system, we need to consider 3 legs, as I said: a good design system, maintenance and inspection. And here I want to say that Camfil can offer in all countries around EMEA ATEX inspection and maintenance on our own equipment. So we can offer you this service. And this needs to be done by properly skilled and prepared personnel. Then it's important that also training and work routine for the people working in the factory is important. And Camfil can also train your people on how to handle our equipment and dust collector and taking measures to avoid possible risky situation. So let's see what happened in case. Let's see some cases where the design was not properly done or there were mistakes. So in this case, for example, we see this ducting that will not probably, this piece of ducting that will not probably withstand an explosion. Maybe the dust collector is completely safe, but if we then have a piece of duct that will collapse in case of an explosion, then we have a high risk, right? So we need to make sure that the entire system is properly designed, not only the dust collector. Here is another case where there was a vent panel properly sized, but then the local maintenance people decide to install a bird screen in front of the vent panel to avoid bird to touch the vent panel. Oh, that's a good idea to avoid the bird to destroy the panel. But what if the explosion will happen? Then the vent panel will not be able to release the explosion, and then, hey, again, troubles. Here, lack of knowledge. I mean, people were not aware that the dust they were handling was explosive. They have been handling the dust for a long time without any trouble. Then one day, somebody decided to perform some welding activity in a pipe, and by mistake, it went through the pipe and went inside with the torch inside the dust, and boom, that's the result. So drastic result. Other cases, somebody decided to perform welding activity on a wood table. Not that great idea. Some training on potential risk for fire need to be done. Or a dust collector with venting and the risk are covered by a glass window on a sidewalk. So in case an explosion will happen, actually people just walking on the street can be in danger. And another case is an electrician, he ran out of cable gland while doing his work and decided to put 2 cables inside the same cable gland, compromising the IP rating of the cable gland. And so we have dust inside the control cabinet, and that's very dangerous because inside the control cabinet there are electricity and things there is heat. So is something where an explosion can start. So this is all things that can be avoided with knowledge, proper knowledge, and with trained people. And another interesting case is this dust collector with a vent panel installed in front of a window. Okay, you don't want that in front of your office, right? So because what will happen in case of an explosion is something like this. Okay, so you don't want to have that coming into your desk, right? So that is another example of poor design. So all in all, what I want to say is that most of the accident can be prevented by knowledge. Knowledge is extremely important. And some accidents are unpredictable, but we can take all the measure to mitigate the consequences. And Camfil can help you in doing this, designing properly our system, in particular for what regard my product line, the dust collectors. So this is all about ATEX from my side. Now, if you have any question, happy to answer. Volker, if you want to come back with me. So thank you.
Interesantísimas las exposiciones tanto de Volker como de Gabriel. Preguntas en relación
Fascinating presentations, both from Volker and Gabriel. Any questions so far?
If something's coming later, you'll meet us again around the demo modules. Don't hesitate to come back with us at that point with more detailed questions when you're actually having your hands on the equipment. Thank you very much.
Tenéis ante vosotros a los mayores especialistas de Camfil.
You
en la
have with you the top specialists of Camfil for this. So please make the most of it. I'm sure that next week you'll go to Pep, to Ricard, to Raul, or to myself to ask questions on this. I mean, this is it. This is your opportunity. Make the most of it. Okay, let's continue then. Next presentation on containment systems for air treatment and dust collection. Alan Zoom, Head of Clean Process in Camfil EMEA, with Gabriel.
Testing. Is this working? Hard look, you get to hear me, so. So today we're going to talk about containment and the Camfil solutions that can help you contain product and protect people. Today, we use HEPA filters in the room to protect ourselves from cross-contamination. Part of your containment strategy should be to identify the hazard and design safely solutions that can fix and help mitigate those hazards. So containment is generally used to contain people from your product from the people, and to stop cross-contamination. It's also used to protect people from the product in the event of exposure or possible explosion. So containment is widely used in the pharmaceutical industry and very widely used in many segments. From high containment labs, right through to nuclear, pharmaceutical, biopharma, security, homeland security in the States. So you'd be surprised at the amount of containment solutions that need to be provided in industry. Camfil have been involved in containment since our inception back in the 60s, in that our first industry we were involved in was nuclear. And that industry is potentially very dangerous, needs a lot of protection. So we really know and are very experienced in containment. We've been involved in, very happy to say, probably up to 70% of the BSL 3 and above facilities in the world. So we know and understand containment, but we also understand and try to use the best solution possible dependent on the risk. You don't need to be fully covered in PPE, wearing breathing apparatus, working in a general safety level 1 laboratory. So again, when we come to our containment solutions, we don't have a one-size-fits-all solution. We started, as I said, in biosafety, and you've got various levels in biosafety. And if you look at them just for a brief few moments, we start at safety level 1. You're typically dealing in a bio facility with products that are not so hazardous. You may get a little bit sick or uncomfortable, but it's not going to be dangerous to the people. So here we use small levels of containment, general ventilation, general handling of waste. The room will probably look something like this. You'll have a protective shower in case something happens in the laboratory inside. You'll have restricted access. You'll have some equipment in the room like perhaps fume cupboards, laminar flow systems. The operators will wear generally white coats, maybe a mask, maybe not, but at the low level of safety that's required. So for that reason, we would choose quite a simple level of a containment product. When it goes to BSL-2, we're going to start dealing with possible HIV, salmonella, compounds in pharma or reagents or organisms in biosafety that will cause some risk. So here we will use some kind of primary containment, generally a HEPA filter somewhere, a better ventilation system. There'll be more hand wash sinks. We start to introduce autoclaves for sterilization into the building. You will definitely be segregating waste. The level of PPE that your operators will use will step up dramatically. But it's still again, you've got to look at the risk. What risk is there? Do you need to go and put in a fully decontaminable, high-end stainless steel, some of your solutions you see outside, or can you choose a simple solution? And again, when you deal with Camfil globally, we can always offer the correct solution to fit the correct hazard. Don't spend 100,000 if you can spend 1,000, but do not spend 1,000 if you need to spend 100,000. We will advise you correctly. When it comes to BSL-3, I don't know whose water this is, but it's now mine. Forgive me. And when it comes to BSL-3, you're definitely going to be working in a biosafety containment facility. You will have very, very, very limited access. As well as supply HEPA filtration, you will now have exhaust HEPA filtration. The laboratory will look dramatically different. It'll be under negative pressure. And the air in the room will stay in the room, will be moved within the room. You will be definitely working in a higher level of PPE for the operators. The autoclave and sterilization systems will now move inside the laboratory, and access is strictly controlled. Airlocks, safety access, restricted barriers, etc. When it comes to BSL-4, I've only been in one in my life. It was not a comfortable experience for two reasons. Number one, I had to remove all my clothing and put on some very fancy apparel, which wasn't comfortable for anybody. And number two, you got to breathe through an airline. So you're going to be dealing with supply HEPA, typically double HEPA, duty and standby. On the exhaust, you're going to have segregated water, duty standby waste systems. You will have the operators wearing breathing suits. So again, you're looking at a very, very, very expensive build of a facility, potentially very dangerous substances inside, which you want to keep inside. So the risk here should be designed with critical containment in mind. But again, as I said in the beginning, we don't have a one-size-fits-all product range. If you're dealing with BSL-4, we will always recommend a CAM contain. If it's a pharmaceutical application, potentially toxic compound, if it's a heavy dust load, you can recommend some of our dust filtration solutions that Gabrielle will discuss. Or we have a range of CAM-safe housings and wall-mounted housings to make the barrier the room, keep the contaminant in the room. If it's a simple containment application, we've got a modular CAM box system. Very inexpensive, relatively inexpensive for a containment product, but suitable for use in low-risk areas. So again, we'll always advise you and choose the correct solution depending on the risk to ensure people are safe at the best total cost of ownership and lowest cost to you as an end user. Brief overview of where we typically use filtration systems in a pharma plant. This is pharma or consumer health. We all know we've got ventilation systems. You've got air handling units on the roof. Today we're in a room where we have relatively clean air coming in through the grills in the ceiling. We're polishing it further by using our CAM cleaner HEPA filters. But typically, when you start to deploy HEPA filters in the industry, you're going to put them after the first range of ventilation filters. So HEPAs, whether they're a deep, typically 4,000 meters cube per hour cell, or whether they're a panel filter, which is typically in a 6x6 by maybe 90, 600 meters cube per hour, they're deployed in housings. This could be after the AHU in a separate housing. It could be in the ceiling, in terminal housings, which we'll show examples of outside and in my colleague's presentation later on. Maybe it's a very, very controlled environment and it's a grade A area or a fully filtered ceiling. And here you might deploy HEPAs in maybe FFUs. So it's a fan and a filter all in one, plug and play, across a whole ceiling, give you unidirectional laminar airflow for our higher grade areas. And then we look at what we're going to emit to atmosphere. So we put housings perhaps on the exhaust side. If you're just protecting from environmental emissions, you put your HEPAs in the wall, H13, H14, and you're protecting the environment from emissions of whatever is being generated or manufactured in the room to the environment. But what if it's a product that higher dust load? You want to keep it in the room, but somebody's got to go changing the filters. Here we've got a range of housings, again, which my colleague will discuss later on, that mount on the wall of your clean room. If there's a spillage of dust, they will have a pre-filter mounted to protect the HEPA. And then the air goes probably on to a further station inside. Maybe there are gases, solvents, or odors involved. You might have a molecular filter in the plant room. Maybe you want to keep your operators safe during the changing of a filter. You've got to bear in mind that even if you're dealing with our friends up in the air handling unit, air filters remove contaminants that we do not want to breathe in. So when your operators or maintenance personnel are changing any filter, including something as simple as an air handling unit filter, have they been trained correctly? Are they wearing the correct PPE? Or if they don't want to do it, can Camfil do it for you? So think about the risk your operators or maintenance personnel may come under and design the correct protocols. When it comes to exhaust, but keeping the personnel safe, you've got a range of bag in, bag out, safe change solutions. So here, you've got a wall-mounted Camsafe. It means that the air will be removed through the outlet grill. It'll go through maybe a first stage, second stage. We can build in scanning, mobile integrity probes, etc. And then the filter is changed in a bag in, bag out procedure, but in the room. So you're not moving the contaminants potentially on to the plant room. But if it goes to the plant room as that dust load gets heavier, we have other options.
Yeah, basically we can use cleanable HEPA filters. In other words, structure where there is an HEPA filter that can be cleaned by a blade of air that allow more a collection of more dust because we clean the filter element. Or if the dust load is higher, then we have a proper dust collector like our Gold series. And here, the amount of dust is really the determinant to decide whether static filter can be used instead of a dust collector. So it's really the concentration of dust, the dust load that need to be handled that is determining whether we can use a static filter or dust collector. Take an example, a process with 3,600 cubic meter an hour, 1 milligram of dust per cubic meter, a filter that can hold up to 500 gram, can retain up to 500 gram of dust. That is quite high number. Such a filter will last only 130 hours. That is not really acceptable in a process, having only 130 hours filter life. So to achieve a reasonable time life for a static filter, we need to have dust concentration at least 3 months. We need to have dust concentration below 0.06 milligram per cubic meter. That means that, to simplify, when the dust concentration is more than 0.05 milligram per cubic meter, then a proper dust collection system should be considered instead of a static filter for dust collection purposes. But there are also some other factors that can be taken into consideration, like the dust properties, whether this dust is sticky or not. Dust collector have some trouble with sticky dust. Space constraint, if we have space or not, and whether the system will be removed, is temporary, or will last long. So when we talk about a self-cleaning system, we basically have two types of machine in the pharmaceutical industry. That is the cleanable HEPA. Basically, is an HEPA filter, as I said before, where there is a blade of air running over the HEPA filter and removing the dust. This is good up to a certain type of dust load, not for heavy, very high dust load application. Or we can have a proper dust collector with a proper cleaning system based on pulse jet air. And here we have a picture of our quad pulse dust collector that is ensure a proper cleaning. You see that we are performing. It can be a compact filter, so also can be used in an application where there is a space constraint. But we don't compromise on the cleaning on the cleaning system, because we never clean more than 25% of the filtering surface, thanks to our special design cleaning system that is cleaning only 1/4 of the filter element at a time. So we can have cleanable HEPA or proper dust collector designed with a proper cleaning system to ensure continuous operation. So basically, what is the right application depends on a series of factors. The most important one is the dust load, the concentration of dust we need to handle, but other factor like and when we like the property of dust and the selection within a static filter, a cleanable HEPA or a dust collector need to take all those information into consideration. So, for example, a static HEPA is good, have a limited space requirement, but it's not good for high dust load, have a low investment, but depending on the dust load, the cost of operation can be pretty high. The cleanable HEPA is a bit a midway. It can be used, is cleanable, so the total cost of ownership will be lower, but an initial investment is in between. And the dust collector is probably the system that have the higher initial investment, but in the long term is the one ensuring the lower total cost of ownership, because the filter element will last long, again, depending on the amount of dust that we need to handle. And when we talk about dust collector at Camfil, we always design dust collector with vertical cartridges that we think is so the filter element are vertical, like we see in the picture here on the left, that we consider to be a superior design compared to the horizontal filters, because in horizontal filter, what happens is that you never clean properly the top part of the cartridge. So it's in some condition, especially when you have some dust that can build up a bit sticky, so you can create a build-up of dust on top of cartridge, while vertical clean it is, and there are no part of the cartridge that remain unclean. Now, we should not forget that in pharmaceutical industry, we deal with the API material, so active pharmaceutical ingredient material, and these are classified in OEB, or occupational exposure band. That the higher is the OEB, the lower is the limit of that can the substance the substance quantity that can be get in contact with operators. And for lower OEB, we can use any type of aspiration system, where when we go higher in the OEB level, we need the system isolator. And this need to be taken into consideration. Coming back to the ATEX presentation before, this needs to be taken into consideration when we made our selection for the ATEX equipment, because we should question ourselves: can we use a vent panel for our for limiting the damages in case of an explosion? Then, in that case, we need to take into consideration whether outside the building we can contaminate with the dust that we handle inside the dust collector, because the vent panel will vent the dust outside. So if we are not able, if we cannot contaminate the outside environment with the type of dust, that's not a good solution. And that's the same. And there are considerations that can be done for all our for all the equipment we offer, up to the, let's say, most safe solution that is a complete offline cleaning, so an isolation of dust collector with 2 fast-acting valve allowed and perform a cleaning that way. It's completely explosion-proof.
So when we think about containment and pharmaceutical, let's talk about emissions first. We want to protect from emissions. The filter, the air filter, is the heart of the system. And as my colleague Benjamin will discuss later on, every single HEPA filter should be tested and certified to EN 1822 or ISO 29463. And importantly, you should receive a test certificate for every single HEPA filters with its unique serial number, date of test, how the test was carried out, etc., etc. Very, very detailed piece of certificate. But what about the housings? A bag in, bag out housing is not just a box with some mechanism of putting a ring and a bag and changing it through a safe change door. That housing should be a safety device. It should be certified. It should be tested. It should be suitable for use as a containment enclosure. Most of the particulates that we filter from the air are quite large and easy to capture when it comes to HEPAs. As Pep discussed earlier on, we typically deal with the MPPS, or most penetrating particle size, which is typically 0.12 or thereabouts of a micron. They're easy to catch. They're going to be in the filter. How dangerous are they? How do you handle them? How do you dispose of them? So we know filters are efficient. We know that according to the standards, they're going to be 99.99, whatever it is. If it's an EN 1822 filter and we want a H14, we can say 99.995. If it's the new, very more transparent and confusing ISO 29463, where they put in some more standards, if you say it's an ISO 45H, it's 99.995. you know, and then they split it to ISO 50 just to be typically pedantic as we do in some countries in the world. But either way, they're very efficient, they're tested, they're certified, and it's clear what they can do when it comes to particle contamination. You get the cert, please ask for the cert, always ensure you can get access to it very easily, as validation personnel and quality personnel in your facility will need it. So again, we have some new ideas on that. But look at the other equipment. We test the filters, every filter, before they leave our facility, wherever that facility is. And as Javier mentioned earlier on, we've got quite a number, quite close to you, no matter where you are in the world. When it gets to site, unfortunately, ISO 14643, which is the test protocol for testing and validating filters on site, has excluded the filters in exhaust or containment systems. And then when it comes to exhaust systems in a wall, you're typically dealing with a filter that you cannot get access to check behind. So what we have come up with and would recommend for this application is what we call a mobile integrity probe. It makes injecting aerosol easier, but more importantly, and Benjamin will discuss this in more detail later on, it will get you a better result. If we just look briefly here, typically you inject aerosol downstream of the filter. You're going to look for 100% concentration before the filter so that you know you're getting the correct concentration of aerosol to perform the test. But if the guy or girl who's introducing the aerosol puts in too small a quantity of aerosol, you may not even be able to pick up the 100%. If it does happen to find a leak in the filter, a static probe downstream may not find that leak. Down below, what does increase the smoke, we need more aerosol in the plant room. What happens? We increase the concentration of aerosol. We're now overloading the filter perhaps. Still looking for the same leak. We will definitely pick up our 100% concentration. Leak is down here. And even with an improved static probe, which is a different shape to hopefully pick up more airflow, there's still a very, very good chance you'll miss that leak. With a mobile integrity probe, and with some of the samples you'll see outside, introduce the aerosol into a mixing chamber. You get a good homogeneous mix, which means you're going to get your 100% correctly. Importantly, the mobile integrity probe covers top to bottom or left to right of the filter, including its meeting with the frame and gaskets. So then when it's moved up or down or left to right, you've got a full possible detection of any leaks on any plane of the filter. That means that you're going to get peace of mind knowing that you're not emitting to atmosphere, that the contaminants that you're trying to filter are staying in the filter, they're not bypassing and potentially contaminating your system. And in the future, anybody who comes in contact with the ductwork or changing the filter. But then, as I said earlier, every single HEPA filter manufactured by every reputable manufacturer, of which Camfil are one, has a test cert. What about the housings? Have the housings you're going to specify as a containment safety device been pressure tested to EN 1886? Have they got a leakage class rate? Have they got a maximum deflection allowance? Has it been tested? Can you get a cert? Is it a real containment device? Anybody can say it's a containment housing. It's got a bag in, bag out door. Has it been tested to 106482 to actually be used as a containment device in temporary or permanent hazardous conditions? Again, if you're specifying or designing equipment, ask for certification, ask for proof. No manufacturer that is of any reputable quality will want to put anything on the market that is not safe and certified. So please ask the question. You guys drive the agenda, you guys and girls drive the specifications, ask for supporting documentation. So that's emissions. The next thing is exposure, and we don't want to be exposed to these hazards. So
we can use people solution, basically bag in, bag out solution, with the main purposes of, okay, the filter itself need to perform correctly, so need to be efficient, need to perform its filtration function in an efficient way, but we want to reduce the chance of human error for contamination and ensure that assure a continuity
during the filter replacement. So BIBO, bag in, bag out system, the purpose is to change the filter element without getting in contact with the dust, and to ensure the continuity of the process. Here we see, I'm going to run through video in parallel where we see the cartridges filter removal from our dust collector, from our Gold Series dust collector, as well as the BIBO change system on a CamSafe HEPA filter housing. So what we can see here is that, well, our procedure for changing the filter element are well documented. There are videos documented them. We have virtual reality procedure, and we can offer all this documentation to properly explain how to perform a proper change of the filter element. And we can see also that it's relatively easy to handle our filters with our BIBO procedure.
Very important to realize that most of your maintenance personnel will not carry out a bag in, bag out change very frequently. If you're using Camfil filters in particular, they're going to last a long time. It's what we do. So when they go to the dust collector or the housing to change a filter, let them refresh their minds to make sure it's done correctly. Again, training keeps people safe. Let them watch the video, use the VR tools, read the O&M manual, but always be sure that they do it. Have a cup of coffee, have a glass of water, read it first before they carry out a procedure which they do not do so often. So keep them safe. And how safe is the housing again? Is it a real safety housing? There are various standards, EN 689 in relation to workplace exposure levels. How much dust are you physically allowed to be exposed to? When it comes to pharmaceutical equipment, ISPE and the SMEPAC committee developed a very comprehensive way to test pharmaceutical equipment, the SMEPAC guide or test. And all of Camfil's safe change or containment equipment is tested to these standards. And it's a very exacting test. I'll give you an example of one of them. To carry out a surrogate test, which is basically you're replicating or mimicking a hazardous compound. So for instance, if we're going to mimic a pharmaceutical type application, we might use glucose or sucrose or lactose or something safe, but which flows and handles an airstream in the same way as the hazardous compounds you guys deal with on site. So what we do is we set up our equipment in the laboratory, and we assess the risk, we decide on our surrogate, we plan who and how we're going to carry out the change of the filtration and the dust collection cartridges in our systems, and we go and run the test whilst the guys are physically performing the act of changing the filter. So we're going to take surface swabs to ensure, number one, it's a laboratory environment. We shouldn't have whatever surrogate we choose should not have been present in the laboratory. So if it's glucose, you go looking for glucose, make sure there's none in the lab. You swab the surfaces around the housing before we start. There's none in the housing. The operators wear breathing apparatus, so we pick up anything from the ambient air during the test. And then they go and they carry out the physical changing of a filter or a dust collector cartridge or the liner or the bin. And all of these swabs are being taken while they're doing this procedure. So you can see many, many swabs, many, many samples from everywhere, including, very importantly, where we actually cut or join the bag, because that's the possible weak link. You've got a filter with hazardous compounds inside a bag to keep you away from that filter, but you're going to cut it to dispose of it. So everywhere is swabbed and tested. And we look for results. And again, as we say, there's a reporting level and a band level. And very happy to say that all of our equipment comfortably meets a level which we can call OEB5. And that includes our dust collector and our CamSafe systems. And we're not the only supplier that has done this, but I would suggest and hope that everybody who chooses to buy a piece of containment equipment asks for that type of test to be carried out. You're dealing with compounds we don't want your staff interacting with. So we should all be pressure tested. All of our housing should be pressure tested. They should be tested for real use as containment enclosures, and they should have had some level of surrogate testing carried out to give you a band or level of contaminants that you know you'll be exposed to potentially and no more. It's not a hard thing to ask from us as filter professionals or from any vendor as a reputable filter manufacturer. but nobody's perfect, believe me. So we're going to again look at some examples of what we have seen over the last number of years, which were far from ideal.
So like we showed you some example of bad design or bad handling for ATEX equipment, also for containment, we can have similar situation. So this is what happened, for example, if the dustbin in a dust collector is not properly designed or is not properly used. So you will have dust falling down on the floor, and if it's a toxic compound, you don't want to have that in your factory. So we need to avoid those situations with a proper system. And here we see a video of a BIBO change on a competitor dust collector, where you may notice in a while it's coming that okay, the system is BIBO, but it's not so easy to use. So how easy is to perform the change, and how is it easy to use to perform the procedure that is required for the BIBO change matter on the safety of the total system. Because you see here that, okay, it's containing, but there is quite a lot of dust falling down, and this is not what we want.
He's trying to carry out the procedure correctly, but the equipment design doesn't allow him. So
you see, there's quite a lot of dust falling down, and why we have quite structured procedure to change in our equipment. And we have always been, as Alan said before, we have been testing the system for OEB5 application.
Just as a footnote to that video, prior to me, I have this video maybe 15 years or more. And before I said, hey guys, can I take a video of you performing this safe change? He said, oh, okay, 1 second. We should go and put on some PPE, because they were wearing shorts and t-shirts, and we're going to carry out this change. Seriously. So training.
So actually they try to perform the best possible way, right? Okay, another things that you can see is like spot welding. Some of the equipment, some of the frame and housing, they are spot welded instead of entirely welding, and there is some silicone gasket that is closing from one welding to another. It can be perfectly okay at the beginning, but over time it can be a major leak for leaks. So our solution are completely welded.
So again, safety and longevity. It's going to be in your plant room or clean room for a long time. It should be designed to last and fully welded if possible. Other issues. We've got some examples here. This is the filter would be installed and the filter would be clamped. But that door is closed and the clamp position is at unclamped. So we've got to engineer out, if possible, any mistakes that your operators can make. Again, here, you've got an attempt at mechanical coding to stop the door being closed while the filter is not clamped, but that's clearly closed and the filter is not at position filter clamped. So again, we have some, and you'll see them on the demos outside, we've some unique little tricks we put in so that even Joe Blogg's dummy Irish here can change the filter correctly and not make a mistake. We have another really well installed filter. Filter is clamped. The guy's going to put the bags and rings on, close the door and go away. Except he hasn't put the filter fully into the box. And now we've got a major bypass issue that when the next operator comes and opens the door, he will be met with a bag full of dust rather than a filter full of dust. So again, it must be not possible to walk away from that housing and leave it in an unsafe position. These are some other little items we found over the years. This one, somebody did a great specification. It's a wall-mounted safe change housing of a type. Removes decontaminated air. Very cleverly has a pre-filter, has a HEPA filter, and then the customer at that stage said, "Hey, Mr. whoever's housing it is, we need access to scan the filter." Oh, okay, we thought about that. So they put a little port that you can remove in the clean room. And your validation engineer, hopefully wearing PPE, can scan the filter whilst looking at what could be potentially contaminated product. Worked for them. I wouldn't scan it, but however. Here we have, again, design. In this instance, you're pushing the air up over the filters. Realistically, if the gasket is facing down, the contaminant goes through the filter rather than around the filter. So there are pros and cons of both, but just be aware of how hazardous your product may be, and should you put it through rather than around the filter, which means the product is not in the bag when you go to change it. Just simple things that we found that maybe are not so user-friendly or safe. My favorite topic, oh my God. If you're buying your safety bags from the local packaging manufacturer, it's not a safety bag. If your supplier of filters buys their safety bags from the local packaging manufacturer, it's not a safety bag. If the gummy ring or the ring is separate, it's less easy to use and there's more people who can make mistakes easier. So please always ask for a real safety bag with some glove holes in, if possible, glove handles for safe manipulation of the filters, easy manipulation of the filters. The easier it is, the less likely people are to make mistakes. So again, all of our bags are specially designed with safety in mind. They're strong, tear-proof, fairly ergonomic design, easy to manipulate. Importantly, you can remove the old bag residue from when you change, you can remove the previous bag residue rather than leave it in, which makes it easier for the next person to do their filter change. We always got to think about who's coming next. Are we leaving it in a safe position for the next person? And again, it's not just a housing with a set of holders for rings. In our case, it's 80mm grooves, deep, good grip on the bag to eliminate mistakes. So look at what you're specifying or buying. And again, because these systems are used to protect people, number one, and then the product from cross-contamination or contamination from those people. So containment is a very, very important part of your strategy when designing. Ask for certified, tested, easy to use solutions. And so for that, we're going to show you very briefly some of the Camfil solutions for containment. And again, we have them on demo outside. So please join us during the break. We can give you a better overview, but just very briefly. And as I said in the beginning, we have a huge range of options from relatively inexpensive through to very, very expensive, critically important components, but we can design appropriately. Camfil will never choose this solution if that's enough. We will always advise and guide correctly. CamSafe 2, which we have outside. CamSafe 2 is the latest generation of our standard bag-in, bag-out housing. As I said already, there are many attributes. It's fully welded. It's got simple items like a door with a window. So you know there's a bag there. There's nothing worse, and it's happened to me on site many years ago, than arriving at a safe change housing, fully garbed up and ready to go, and there's no bag there. So now you got to go and ring up maintenance. Sorry, buddy, we've got to close down your plant room. We're going to remove this filter. We're going to have contamination. You're going to have to come and clean. So a simple addition of a window means you know that the bag is there. Again, the clamping device, as you'll see outside, it is impossible to close this device unless the filter is fully seated. Simple change, but a big difference for operators and this process. They cannot get it wrong. The bag is designed to be a safe change bag. It's got integral arms or ports or gloves to manipulate the filter correctly, to adjust the clamps correctly, without needing to try and do it through a non-safe plastic bag. So again, simple design features. And it's not, again, as I said, it's not just a range of safe change housings that happen to have a BEBO door. They're tested to EN 689 for pressure. They're tested according to the good practice guides from SMEPAC, and we have the results. And again, as I said, simple tricks so that you cannot get it wrong. You cannot not fit the filter incorrectly. You cannot close the door without it being clamped. Simple, simple, simple for safety. It's available in lots of different options. I'll go into that much more when I look at the configurator. Again, it can be a single housing, a wall-mounted housing with duct-mounted connections, etc. And again, the latest iteration, CamSafe wall-mounted, which means your safe change housing is now in the clean room. The contaminant does not leave your production area, but there's lots of accessories to build it up, hide it in your clean room wall, aesthetically pleasing, very safe. Lots of different options and add-on modules. And this is where it starts to get difficult to perhaps configure and design. But we've got some tools later on to help you do that. Then we have dust.
And then we have dust.
I'm the
Very
clean,
high
I'm the
dust
clean
level.
guy. He's a dirty guy. That's the way it works.
Unfortunately, I'm the dirty guy. Okay. Again, that's the range of our dust collector for pharmaceutical industry. We have a full range of dust collector specifically designed for pharmaceutical dust application. Our general purpose gold series contain dust collector, gold series HV, so for high vacuum cleaning. The QPP series, quad pulse pulsing series, that are designed for application where there is space constraint, where it's a compact solution, safe and compact. So let's go in some more details about those systems. Our gold series contain dust collector. It's our dust collector general purpose for pharmaceutical application and can be used in tablet pressing, tablet coating, blending, general ventilation room, granulation, chemical processing, spray drying, fluid drying. Basically, it can be applied to any dust collector application in the pharmaceutical industry. And it's a modular system, 2, 4, 5, 6, 8, 10, 12, and ahead cartridges, so it can adapt to any volume required for your specific application. It includes our bag in, bag out filter change design, and also it can include a bag in, bag out for the discharge system. The discharge system we see in the picture here is our dual valve continuous liner discharge system. That is the one that has been tested up to OEB 5 on the cigarette test. So the dust collectors it has been tested for being safely used on certain for certain OEB requirement. And it has been designed with maintenance and easy of use in mind. In case an HEPA filter is required, it can be combined with the Camfil in the as a secondary stage of filtration. The quad pulse dust collector, the quad pulse, the name comes from the cleaning system. I briefly introduced that before. So this system can be equipped with 1 or 2 filter elements, but even when we have 1 filter element, we ensure that we don't clean more than 25% of the cleaning of the filtering surface at the same time, ensuring a perfect and continuous operation from the extraction. This is something we have here aside. I'm happy to talk with you about that later on. And one key features about this dust collector is that in case an explosion will happen, the explosion will remain inside the dust collector. So we see in this picture, you see we see a lot of flame here. So that means, when explosion will happen in this chamber, it will remain here, and and the primary filter will already be a good first barrier for the propagation of flame. It will probably be okay in most of the cases, but we certify the HEPA filter that is installed in this dust collector as a secondary barrier for flame. So it will ensure that the flame will not propagate outside in case. Of course, the flame can still propagate back in the process. So we need to install a fast acting valve to make sure that the system is isolated in case of explosion. This system can be used also for high vacuum application down to -25 kilopascal, so for vacuum cleaning application. And it's designed for application where you have space constraint. So the system is a unique box turnkey. It can the version with only one filter element can also have an integrated fan, so it comes as a standalone unit, and it can pass through a door, so it can easily be installed in laboratories for pharmaceutical application.
Just to on all of our housings, just remember that we always design with some key attributes in mind. All our safety products are fully welded. We have double safety at filter positioning, or in the case of the QPP, we've got double safety with both the pre and final filter certified as explosion barriers. And again, that's just, as we say in Ireland, to be sure. If you can make it twice as safe, make it twice as safe. All of our products are designed for safe BEPO operation. They're designed as bag in, bag out housings. They're not just designed as a housing with an add-on door later on in its product journey. And they're all very modular. I showed some examples earlier on of building up a system which can be quite complex, but they're complex but made of modular parts. So it's easy to design, easy to specify, easy to install, easy to transport. It's a crack with this thing. Sorry. They're not all simple and easy. Some of them are very high tech, very, very, very unfortunately expensive, but it's to provide a very, very safe solution in typically BSL sites. And before I talk about this and show you a small video, I just want to bear in mind, like, we've learned what we've learned over the years from dealing with hazardous compounds and with handling filters in these pharmaceutical environments where they're not just filtering air, they're being tested and validated. So they've got to be suitable for use and have no bad effect made on them by the introduction of testing aerosols. I love the pharma industry, but my God, are you guys clean? You clean everything. So you're cleaning ductwork, you're cleaning filters, you're cleaning grills. Are they cleaning compounds? Are the filters suitable for use with those cleaning compounds? You're going to use maybe ethylene oxide or hydrogen peroxide or other decontaminants and flood the filter with 1,000, 2,000, 3,000 ppms of these decontaminants. And previously, we then got the call, hey, Sweeney, your filter's gone brown. Sorry, why? What did you do? Oh, we introduced Sunback or some crazy compound. You never told us you were going to do that. We didn't think we had to. So now you don't. Outside, you're going to see a range of filters that are called ProSafe. And we did that because, again, to bring on the industry, we wanted to improve what we're offering to the industry. So all of the ProSafe range can be used in food grade applications, in antimicrobial applications. They're suitable for cleaning or decontamination with some of the crazy stuff you guys use on site. If you have anything new you're going to try on site, please let us know and we'll test that as well. We do not want to have a filter in an application that causes problems at any term in the future. So please let us know what you're going to do and we can expand their testing criteria. But going back to Camcontain. Camcontain is our highest level of safety housing. Small video here that we need to change the name on, by the way, David. I just noticed that. Here we go. Sorry, forgive me. You're going to love this because I got to speak really slowly because it takes so long. So this is this high-end containment housing. You can see the bubble-tight dampers. You can see inside, when we get in more detail, that it has facilities to help you test and decontaminate safely. So we turn on the airflow, opening the door for easy view. You also need to remove about half of the filling. So turn on the airflow, you've got contaminated air going through the filter. The filter will catch the contaminants, obviously, it's what it's there to do. Clean air exits on the right-hand side. And at some stage, you've got to change the filter. In this housing, you might notice that there are gaskets both sides. So the filter is clamped on both sides with a gasket. So all of the contaminants go through the filter. So before we start, close and isolate the housing, dehumidify the filters. And again, now all the dehumidification compound is going through the filter. It doesn't go around it, it goes through it, which means in effect, this housing, whilst it's a safe change housing, because we're going to decontaminate the filter and the contaminants next, it could really be used without the door. But the door is left there as the last line of defense. You should be dealing with a clean filter when you're finished decontaminating. And again, we've got methods to check that the filter is clean, depending on the level of laboratory you're operating in. And we can tell you exactly what percentage of kill will be achieved during decontamination. Dynamic gasket. We wish you had the fast forward button. So again, after decontamination, dehumidify. Also, while the housing is fully isolated, and then you would carry out the safe change, bag in, bag out, filter change. Still carried out in a bag, but in this case, not 100% necessary. But you want to keep your people still away from any residual decontaminating agent, et cetera, et cetera. And just very briefly, as I said already, here we have, sorry, the next one. You've got gasket on the inlet, which is a DIN gasket if needed, so you can actually test the pressure to make sure that it is sealed correctly. Gasket on the outlet, which means by default that everything goes through the filter. So in reality, the bag in, bag out bag might not be necessary, but it's left there as the last line of defense. So again, we won't offer you this if a can box will do, but we equally cannot quote you a can box if you're dealing with something that we know is particularly nasty. So we'll always design dependent on the risk that we need to protect you and your people from. So what can Camfil offer in general? I'd like to say everything. Probably nearly can. Obviously, replacement filters, not just for Camfil equipment, but for most other brands on the market. We are equal to or better than every filter manufacturer. And for those online, I have no problem saying that, even if you're a competitor. We have individually tested HEPAs and housings. Every one of our HEPAs is individually tested, no matter what the range. No batch tests. Every single filter is a unique serial number to ensure that it's compliant with the relevant legislation. Full list is there as to what we can do. Importantly now, in most countries in Europe, particularly in our own equipment, we can offer service, maintenance, validation if required, which takes the onus off you and your people to perform some of these safe change procedures that they may or may not be familiar with. But we also offer some online tools. We've got a huge range of Creo, which is a consultant tool to help you design and tweak your clean rooms to make them more energy efficient by maybe reducing the airflows, but keeping it within specification, and the program will advise you. We've got LCC, which is a program for your ventilation systems, where you can plug in whatever filters you're using, give you another piece of advice as to what filter you might choose, and it'll calculate the energy savings that you can make by changing something as simple as an air filter. And again, as we show you outside, and Pep spoke about earlier on, all air filters are rated now like your refrigerator, A to E for energy ratings. So we can show you with calculations the effect of using an A versus a B and how much money in real terms you can save for your facility. And a lot of our equipment we know is a little bit complicated. So now we've come up with what we call a configurator. And configurator or consultant portal is something that we can offer you guys as clients that adds value to your system and that you haven't got to engage too much time in designing what can be quite a complex solution. So again, this will be on demo outside during our coffee break and walk around. Please have a look at the consultant portal, configurator, and you'll see how easy it is to use. We originally started this off with 6 product lines. We've now gone to 11. Which it means you can basically go for a large capital equipment project, have a talk with your Camfil contact. They will suggest a product that might be suitable for your solution. And then with him or her or on your own, you can go and configure by clicking the housing, the accessories, and build from a simple housing right through to a very complex housing in a matter of minutes. That makes it efficient for you in the design process and efficient for us in that we know what you want and we can help you and tweak it if needed. But a lot of the work's been done so you can get a price very quickly, know what you're going to get when it's delivered. So we have obviously drawings or real life examples. Same thing for CamSafe. You start off with your airflow, number of cells you need, and very quickly you can see here it generates a budget price for a system with the options you've chosen in a matter of minutes. It also importantly spits out drawings. Drawings that you can copy and, drawings that you can manipulate. You can zoom in and get real dimensions for bolt fittings, connections. You can, if you want, manipulate it to change its position in your design. You can, if you want, turn it upside down, but I don't recommend it. It goes on. So again, it can split the components for you into modular drawings, a drawing for each if you need it, or if not, it puts together a drawing for the whole item that you integrate into your building. But again, it's to make it easy, design process easy for you guys. So to summarize, the portal will make it easier to design. Currently 7 product lines, it's just been extended. It can spit out over 3,000 Revit drawings. And we know it's not the only solution of this type on the market. There's about 21 different kits and products and prices in it. But it's not just to give you an individual price for a product. Other people do this. This is to give you a solution. You can design and pick a solution to suit the problem you have. Not just go online and buy a simple maybe not fit for purpose product. So please, if you want to get involved with it, let me know, let the guys know. We can give you some sign-in credentials. You can mess around with it and use it at your leisure. If you want to learn any more about pharma or containment, we have published many white papers. We've got many podcasts available on the internet somewhere that I don't really know much about, but it's there for you to listen to. And we've always got these events or other events in other areas. So please join in and let's talk about clean air and make the pharmaceutical industry as safe as possible on both the dirty and the clean side. Any questions?
Like to say something on the dirty side, just to reinforce a concept Alan said before. We can offer replacement filter for the vast majority of the dust collectors that are on the pharmaceutical market. So our dust collector, competitive dust collector, we can offer replacement filter together with the service of replacing the filter element all around EMEA for the vast majority of the dust collectors that are on the market. High quality filter for the vast majority of the dust collectors that are on the market.
Now we get to ask the important question. Are there any questions? Which means nobody understood a word I said if there's not, or else nobody cares. Any questions on any topic so far? Well then guys, we're outside. Maybe you can explain how the break works. We're going to be outside to take questions and show you some products. Thank you.
Muchas gracias, Alan. Gabriel. Vamos a hacer ahora una pausa para el café que durará.
Great. So we're going to have a coffee break, 15 or 20 minutes. After that, we're going to have a tour to physically see the products and services that we've been discussing in all these presentations. So as you leave the room, you're going to see 6 positions, 6 stands. In each stand, there will be Camfil personnel introducing the unit and providing answers to any questions you may have. So these 6 stands are color-coded. Each stand is a different color. You will receive an indicator with a color. That's your starting point. And then we will rotate every 10 minutes so that everybody gets to see all the stands. And we will be back for presentations at 1 o'clock. Let's go for coffee.